everyone, this is Ankit from Kailasha Foundation Fun and Learn portal. This is your first formal lecture of permutations and combination, or you can say second lecture, because in the first lecture I gave you the basics about factorial notation, and I told you about arrangements and selections, and the two formula NPR and NCR, where to use which one of those. Okay, so here I will describe you this chapter from the very beginning, and I will start from fundamental principle of counting. Okay, and before fundamental principle of counting, let us discuss some things about counting. So, when you were a child, you started learning. When you started learning, the first thing you did was counting one, two, three, four, five, so on. Whenever you counted things, you didn't start from 0 or 0.5 or 1.5. You always did so from 1. You started always from 1. Okay, and starting from 1, you never went in decimals. You always did 1 after 2 after 1 and 3 after 2. So 1, 2, 3, 4, and so on. Okay, this was your counting. So the numbers which you naturally use in counting are called natural numbers, and we always use natural numbers only in counting. Okay. This chapter, particularly permutations and combinations, in this entire chapter, what you will do is counting, but this will be different. Okay, this will be different because if you have to start counting from 1, 2, 3, 4, and so on, and you have to go this way only, and no shortcuts and skippings, you just have to go to some thousands or lakhs. It will not be practically possible for you in example. Okay, so there must be some techniques, there must be some formula, and that's what permutations and combinations is all about. So in permutations and combinations, you will learn the questions like, in how many ways can we rearrange the letters of the word computer? So COMPUTER, there are 8 letters, and we can jumble these. And remember that we are not going to make meaningful words only. Okay, uh, we will be making any kind of words, may be meaningful or may not be meaningful. Okay, that doesn't matter. We just have to form words. So because it is asking only for rearrangements. Okay, it is not asking for meaningful words, but it is asking for rearrangements. So in how many ways? See, this question is also in how many ways. In how many ways can we rearrange the letters of the word computer? Any question, any question in this chapter you'll see will be like this only. It will start with the phrase in how many ways. Okay. Every question in this chapter, almost every question in this chapter will start with the phrase in how many ways. Okay. So assuming that you learned about factorials in the previous lecture I gave you, I am going to start fundamental principle of counting. So here is fundamental principle of counting. Okay, fundamental principle of counting. Counting is basically when we are given with the term and, then we usually use multiplication, and when we are given with or, we use plus. I'll tell you how with suitable examples. Okay, a man has to go to Delhi and return. A man has to go to Delhi from Patna. Okay, from Patna, a man has to go to Delhi and return. Okay, there are 10 buses and 8 trains between Patna and Delhi. There are 10 buses and 8 trains between Patna and Delhi. Okay, a man has to go from Patna to Delhi and return. A man has to go from Patna to Delhi and return. There are 10 buses and 8 trains between Patna and Delhi. Okay, in how many ways, in how many ways can this man go by bus? In how many ways can this man go by bus and return by train? In how many ways can this man go by bus and return by train? That is the first question. And there are 10 buses and 8 trains. So usually what students do, they add 10 plus 8, because they say that for going we have 10 options and for coming we have 8 options. So 10 plus 8, that is 18, but that is completely wrong. The answer in this case will be 80. And the second question is, in how many ways can the man go from Patna to Delhi by any means? In how many ways can the man go from Patna to Delhi by any means? So in this case, the answer is 18. And now I am telling you the rule of and or. In the first case, the man has to go from Patna to Delhi. So he has 10 options for going. He has 10 options for going, and he has to return also, and he has 8 options to return. 10 to go and 8 to return. 10 to go and 8 to return. In the second case, he has to he has 10 buses or 10 buses or 8 trains. He cannot use both. He has to use one of these, either bus or train. So he cannot use both. So he has 10 buses or 8 trains. So 10 plus is that 8, that is 18. And in the first case, 10 into 8, that is 80. That is the rule of and or. So whenever we are provided with and, we will do multiplication. Whenever we are provided with or, we will do addition. Okay. And what is the meaning of fundamental principle of counting here? Whenever we were counting, for the repeated counting, we were adding. Okay, say we counted from 1 to 3, then again we counted from 1 to 5, then total counting was 3 plus 5. Okay, so addition was there. For repeated counting, we used addition, and for repeated addition, we used multiplication. Okay, so in some cases we will be multiplying things where there will be and in other cases we will be using addition where there will be or. Okay, so this is the fundamental principle of counting you have to be aware of. Now I'm giving you an example. In how many ways can 4 men A, B, C and D be arranged in a row? In how many ways can 4 men A, B, C and D be arranged in a row? That is the question. So what we can do? A, B, C, D, A, B, D, C, A, C, B, D, A, C, D, B, A, D, B, C. But this process will take time. This process will take time, okay? Because this counting is very hectic, and we have to avoid this trouble in counting. That's why we are studying this chapter, because this way everyone could count by the long process. Though it takes time, but even a rickshaw puller or even anyone who doesn't know math, uh, anyone can do this type of counting. Okay, so we have to apply math so that our counting becomes easier. Okay, so four places are there to be filled by four people. For the first place to be filled, we have four options. For the first place to be filled, we have four options. We can fill any one of them at this place. Say we filled the place by C. So C is gone. Okay. Now for the second place, we have three options. A, B and D. Okay. So what if we filled the first one with B? Then also we were having three cases only for the second place. Okay. The mathematics doesn't change if we change our options. Okay. Now tell me what, for the first case we had four options and we have three options for the second case. And yes, and is there, so multiply, because we don't have an option to fill a few places. We have to fill all the places. We have to fill all the places. So there will be and every time. Now for the second place there were three options. Say we filled that one with A. Now we have two options, and then again for the last place we have one option. So 4 into 3 into 2 into 1, that is 24. Now tell me, isn't it 4 factorial? So four different things to be arranged at four places, it is 4 factorial. Four different things, keep in mind. Four different things. Four different things to be arranged at four different places. The number of arrangements will be 4 factorial. Five things, five places, 5 factorial. N things, n places, n factorial. So the first formula which you are learning today is the number of ways in which n different things n different things can be arranged at n different places is n factorial. Okay, n factorial. So we know that if we have to arrange three things at three places, A, B, C, A, C, B, uh, B, A, C, B, C, A, C, A, B, and C, B, A. We have six arrangements. Does the formula apply to this case? Yes, three things, three factorial, that is six. Okay. Now, why I am giving emphasis on this different? The things must be different. Otherwise, if it is A, A, B, okay, then what will be the case? A, A, B is one arrangement. Then A, B, A. Okay. Then B, A, A. Only three arrangements will be there. The number of arrangements decrease. When repetitions are there, then the number of arrangements decrease. Okay. When repetitions are there, the number of arrangements decrease. So for the formula to work, for this direct formula, so what we will do if repetitions are there, that I will tell you, in the due course of the chapter. But at first, if you are going to apply this particular formula, then keep in mind that there are n different things. As many things, that many places. If five things, then five places must be there, not six places or four places. Say you are arranging five things on four places and one thing remains unallotted. In that case, the formula may not apply. So keep in mind that if there are n things, then there must be n places, and all things must be different. Then this formula will be applied, and the arrangement must not be circular. It has to be linear. Okay, because I have clearly written different places, and when we will learn circular permutations, you will understand this, the meaning of this different in that case. Okay, the relevance of the different term in circular permutation you will get to learn. So the number of ways in which n different things can be arranged at n different places is n factorial, and now you are getting a gist of the chapter. That in this chapter you will have questions like, in how many ways we can arrange this, in how many ways we can do this, in how many ways. Say, see one question: how many diagonals are there in a decagon? Yes, this is also a question. So these type of questions you will learn in this chapter. A man had six friends. In how many ways? A man has six friends. In how many ways can he invite one or more of his friend to his birthday party? Okay. A man had six friends. In how many ways can he invite one or more of his friends to his birthday party? So these are the cases, and in these are the questions, and in every question you see there will be the term in how many ways, or how many ways are there. Okay, so and factorial will be used in almost every question. The first focus is on different things. When things are not different, a few things are repeated or identical, then the number of permutations decrease. Okay, you learned in the previous video, in the previous basic video, in which I told you about the formula of arrangement and selection. I told you about NPR and NCR. There you learned that uh, in selection we are using different formula, in arrangement we are using different formula, and in those two formula also the things were different, and different things take an hour at a time. In both formula we were using the same thing, and different things take an hour at a time. Okay, so in this chapter what you will see now, you are understanding. So let us proceed. Factorial notation. Zero factorial is 1. How? That I promised you in the previous video that I will tell you how 0 factorial is equal to 1. So uh, tell me one thing: in how many ways can we not arrange anything? There's one way to not do anything. So the number of ways to arrange zero things is 0 factorial, and there is that must be 1, because there is one way to not do anything. Okay, if someone asks in how many ways you will not do something, so there is one way: I'll not do that thing. Okay, I'll not do that thing. So that is also a way. So that is one way. In this way, that is one way of explaining how 0 factorial is equal to 1. Now another way is uh, NPN. What is NPN? The number of ways of arranging n things taken, all of them at a time. Okay, 8p8, say 8p8. I have 8 things and I have to arrange all of them at 8 different places. So 8p8 is the formula, but we just learned that 8 factorial also does the job. Okay, in same way, for n things, npn is the formula, but we know that n factorial also does the job. What is the formula for npn? N factorial by n minus n factorial. Okay, so 1 upon 0 factorial is equal to 1. Taking reciprocal, 0 factorial is equal to 1. So this way it looks more justified that 0 factorial is equal to 1. Factorials of only natural numbers are defined. NCR is equal to 1, and when n is equal to r, combinations represented by NCR can be defined as the number of ways combinations NCR where in which r things at a time can be selected from amongst the n things available for selection. The keyword here is selection. Okay, that I told you in the previous video. NCR is equal to number of combinations of n things taken r at a time. NCR, the formula is this, I told you already. Some typical situations where selection is used: selection of people for a team, a party, a job, an office, and so on. Okay, and clearly, when we are deciding this team, when the term team is there, uh, there is no concept of team leader or captain or vice captain readily. That will be decided after selection of team, and that will be a different case. But at first, if we have to select 11 people, then that is selection. Okay. 11, there is no 1 2 3 4 5 6, the position or order is not there, then that is selection. If there is order, then that will not be selection, that will be arrangement. Okay, selection of a set of objects like letters, hats, point pants, points, pants, shirts from amongst another larger set available for the selection. So whenever you are picking things, and after picking you are not going to arrange them or allot them positions, okay, then that is selection. Any selection in which the order of selection holds no importance, order holds no importance, then that is combination or selection. Okay, permutations can be defined as the number of ways in which r things taken at a time can be selected and arranged also. Okay, how does the formula work? The formula for selection is what? N factorial by r factorial, n minus r factorial. So r things are selected, clear? R things are selected, all those are different. In how many ways can we arrange R things? R factorial, then this and this is cancelled, and this becomes the formula of permutation. That's it. I told you the formula for permutation is this. See, this is the formula, this is the formula. In other words, permutations can also be referred to an ordered selection. If the selection is accompanied by order, then it is permutation. NPR is equal to number of permutations of n things taken r at a time. Okay. Some typical situations where ordered selection permutations are used: making words and numbers from a set of available letters. So when I am making a word, then the order of letters is becomes very important. Okay. Filling posts with people, because there are posts. Okay, particular post will be allotted to particular person, so order is there, order is involved. Selection of batting order of a cricket team of 11 from 16 members, obviously that is arrangement. Putting distinct objects or people in distinct places. Okay. So this is place allotment, this is obviously arrangement. The exact difference between selection and arrangement can be seen through the illustration below that I have given you the PDF already. You have to learn that by reading the PDF. And I have clearly devoted a particular short lecture already for describing you arrangement and selection. If still you have some doubts, you can send me on WhatsApp. Okay. The relationship between permutation and combination I already told you. When you multiply NCR by R factorial, you get the number of permutations. MNP rule, that is multiplication. I already told you the fundamental principle of counting. So in this PDF, it is described in a different way, alternative way. This one is addition, and this one is multiplication, and this one is addition. So that's what I told you already in a different way. Important results. The following results are important as they help in problem solving. Number of permutations of n things all at a time. I told you this, and you can also say npn. Okay. Number of permutations of n things out of which. Okay, this we will see. We are not going to learn this right now. We will be going slowly through the chapter, and then we will arrive at the questions of repetition, and then we will use this case. Okay, now we have illustrations. Mm, there are these 21 points which we will go through for doing the chapter. Now there is circular permutation. So before just jumping to the next topic, we have to do a few questions of permutations and combinations for basics. Okay, for clearing our basics, we'll do a few questions. Okay, these are a few questions for you. 4p3 is evaluated as, that is 4 factorial by 4 minus 3, that is 1 factorial. 24 by 1, that is 24. 4p4 is equal to 4 factorial, that is 24. 7 factorial is 5040, that I told you to learn. 0 factorial is a symbol equal to 1. In NPR, n is always an integer, a positive integer. C is a better option. In NPR, the restriction is n is greater than or equal to r, because you cannot select more things out of less things. You cannot select 10 things out of 8 things. So n must always be greater than or equal to r. Okay. In NPR, n is equal to this. Then we have to count 1, 2, 3, 4, and so on. So what is the counting from here to here? What is the total counting? It is always r. Whenever there is NPR, then this counting of factors is r. Okay. See, uh, for example, we take 4p3. So it is 4 factorial by 4 minus 3, that is 1 factorial. So 4 into 3 into 2 into 1, and we do like this only. So what is this? It is 4 into 3 into 2. So how many factors are the 1, 2, and 3 factors are there? Okay. So what was here in place of r? It was 3. So there were 3 factors. In the same way, whenever there will be r, the number of factors will be r. NPR can also be written as this one. If NP4 is equal to 12 times NP2, if NP4 is equal to 12 times NP2, then N is equal to. So what we can do, we can take this side in the denominator. So NP4 by NP2 is equal to 12. Okay. N factorial by N minus 4 factorial, and this one is N factorial by N minus 2 factorial is equal to 12. This one, these two are cancelled. Now what remains? N minus 2 factorial by n minus 4 factorial is equal to 12. N minus 2, then we go one less, n minus 3, then n minus 4, and so on up to 1. But from n minus 4 to 1, it will be n minus 4 factorial, and the denominator is already n minus 4 factorial waiting for it. So it will be cancelled. You can do this in two ways. One is quadratic equations. Okay. And the other is, these are two consecutive numbers, because n minus 2 and n minus 3, there is the difference of 1, and 12 you can write in these two ways, for in this way, 4 into 3. Okay, this is two consecutive integer pair. So the bigger one is 4, and here n minus 2, so n minus 2 is equal to 4, n is equal to 6. Done. Okay. This one also, np3 by np2 is equal to 3. 10 number also you can do this way, on in the same way. Okay. So these were a few basic questions. Now we are jumping to these word problems. The number of ways the letters of the word computer can be rearranged. So computer, there are 8 letters. 8 factorial is 40,320, but the term here used is rearranged. So one arrangement is the computer itself. So we will count one less. So it is 40,319. Students always do mistake doing this. Okay. The number of arrangements of the letter in the word failure, so that vowels are always together. When it is asking for vowels being together, we tie vowels together. A, I, U, E, we tie them together. Now FLR remains. If we tie them, it seems like one unit only. 1, 2, 3, 4. We have to arrange these only. So 4 factorial is 24. But inside, they can rearrange among themselves. So that is again 4 factorial, and these two things are simultaneous, that means and, so it will be multiply. 24 into 24, that is 576. Okay. Then again, looking for relevant questions, what we have studied so far, there is a question number 18. If 12 school teams are participating in a quiz contest, the number of is the first, second, and third. So positions are there. So it is an arrangement. 3 out of 12 we have to pick. So 12P3 will be the answer. So 12 into 10 into 12 into 11 into 10. Because here is 3, so 3 factors. 1, 2, 3. It is 1320. Okay. Now we will learn more basics and then we will arrive at these questions which are left: 11, 12, 13, 16, 17, 19. Okay. First we will learn more basics and then we will arrive at these types of questions. So this is the first lecture of permutations for you. If you are getting it, if you like the speed, if you like the flow, if you are understanding the audio, if there is no problem with the language, if everything is good, tell me in comments, tell me over WhatsApp, tell me anywhere you can, and then I will continue the lecture. Please tell me as soon as possible. Okay. Thanks for watching this video. Don't forget to like, share, and subscribe. Thank you so much. Happy learning. Bye bye.